Hello friends, today I will discuss about restricted earth fault relay in case of three-phase autotransformer. In this video we will discuss about REF relay for 160 MVA 220 kV by 132 kV three-phase autotransformer. Since in case of autotransformer there exists only one winding in each phases, therefore, the REF relay is taken from HV side and LV side and neutral side CT and fed to the REF relay. The diagram for restricted earth fault relay has been shown in this diagram. Here, the three set of CT has been shown. That is, one set of CT for each phase taken in the HV side, another set of 3 CT taken in the LV side, and one number of CT, that is NCT, in the neutral side. The polarity arrangement should be proper in case of REF relay. That is, for each phase CT, either HV or LV, bus side should be connected to the P1 side of the CT, and line side, that is our transformer side, should be connected to the P2 side of the CT. And for NCT or neutral CT, the P1 should be connected to the R side and P2 should be connected to the neutral of the transformer. Similarly, secondary side of the CT, for each phase CT and neutral CT, all S1 are taken together and sorted and fed to the one terminal of the REF relay, and all the S2 terminal of phase CT of HV and LV and NCT are taken together and fed to the REF relay. For proper operation of REF relay, all the CT ratio, that is each phase CT and NCT ratio, should be equal, otherwise maloperation will be occur. That is, if phase CT of the HV side of the CT is 800 by 1, then LV side should be 800 by 1, and for NCT it must be 800 by 1. Now, under through fault condition, the REF relay will be maintain a stable condition. The arrangement has been shown in this diagram. In this diagram, a fault occur in the LV side CT. After the CT, the fault current will be fed, and the direction of the fault current has been shown by green line. From the HV side, the fault current will be fed from the HV side. CT will be from the direction P1 to P2, and from the LV side it will be from P2 to P1, and from the NCT it will be from P1 to P2. The current fed from the HV side CT is I1, and from LV side CT is I, and from NCT is I2. Since the direction of the current from LV side CT is reverse from the HV and NCT, the total current to the relay will be equal to 0. Here I is equal to I1 plus I2. Now let us consider at the fault point if the fault current is 2200 ampere. This fault current will be fed from the HV side CT and the neutral side CT or NCT as shown in this diagram. From HV side CT R phase CT secondary, current will be flow from S2 to S1, since in the primary side the current direction is from P1 to P2. Therefore, the current in the secondary in the HV side CT will be equal to 1320 by 800 ampere, equal to 1.65 ampere. Similarly, in the LV side CT has the current direction from P2 to P1. The direction of the current in the LV secondary will be S1 to S2, equal to 2200 by 800, equal to 2.75 ampere. From NCT, the current flows from S2 to S1 equal to 880, it will be 880 ampere. as the rest of the current will be supplied by NCT, and secondary side the current will be 880 by 800 equal to 1.1 ampere. Since the direction of the current in the LV side CT is S1 to S2 is equal and reverse to the direction of the sum of the current to the HV side and NCT from S2 to S1, the current through the 64 or RF relay will be equal to 0. Hence, the relay maintain a stable condition. Now, let us consider a fault occur in the inside the restricted zone, that is from the LV side CT to the towards the direction of the transformer at point F, and fault current is 8800 ampere. The direction of the fault current as shown in this diagram. From LV side CT it will be from P1 to P2, and the value of the current is 4400 ampere, and from the HV side CT it will be again from P1 to P2, and the value of the current is 2640 ampere, and rest of the current will be fed from the NCT. Again the NCT will fed from the current in the direction from P1 to P2 via earth. The magnitude of the current will be 1760 ampere. Since all the current is from P1 to P2, all the secondary current from the phase CT, NCT and HV side CT will be from S2 to S1, and these three current will be additive in nature, and thereby all the current secondary current will feed to the relay, and thereby it will trip the circuit breaker associated with the fault. Now what is the function of the resistance connected in series with the RF relay? The function of the resistance is to avoid any maloperation due to CT saturation in either side of the transformer. That is, if any CT saturate during the earth fault, it will prevent for maloperation due to CT saturation. Now, how to calculate the resistance value? To calculate the value of the resistance, we have to know the capacity of the transformer and also the percentage impedance. Here the capacity is 160 MVA and HV side is 220 kV and LV side is 132 kV, and percentage impedance is 12.5%. Therefore, full load current in HV side will be equal to 420 ampere, and in the LV side it will be 700 ampere. Since maximum current is in the LV side, the maximum fault current will be fed under through fault condition will be from the LV side equal to 700 by 0.125 equal to 5600 ampere. Secondary value of the IF during maximum through fault condition will be equal to 7 ampere, as the CT ratio is 800 by 1 ampere. Now let us consider the resistance for RCT, that is CT secondary resistance, as 3 ohm, and the cable from CT secondary box to the panel is being considered as 5 ohm, that is R cable equal to 5 ohm. Then the maximum voltage drop during maximum through fault condition will be equal to RCT plus R cable into IF, which comes as 56 volt. If the setting is 0.1 ampere, then the value of the resistor will come as R equal to VD by I set equal to 560 ohm. For safety purpose, I set is set slightly higher. In this case, we consider as 580 ohm. In this way, we can calculate the value of the resistance.